Alan Turing, often considered one of, if not the most influential and ingenious people in computing history, his work laid the foundation for modern computers, earning him the title of the father of computer science. 1936. Mathematicians started to become very concerned when they realized they had no official way to know whether a problem was valid, as some functions seemed to run for an indefinite amount of time. This was known as the Entscheidungsproblem. Turing had a revelation. He imagined a machine with an infinitely long tape from which you can read and write as many times as you wanted. If the machine could solve the problem in a finite amount of time, no matter how long, it was valid. A Turing machine isn't so much an actual machine as it is a theoretical mathematical concept, similar to Laplace's demon. Imagine there was a demon that knew every single variable in the observable universe, every particle's momentum, direction, acceleration, etc. Although not real, if such a demon existed, applying the deterministic laws of physics, it would theoretically know everything that ever happened or will happen at any point in time. It would know the date of your wedding, and who you were to be married to. It would know how and when you would die. It would even know how and when the sun would collapse and the end of the universe it lives in. While a Turing machine with an infinitely long tape doesn't and could never exist, we can and have constructed simplified Turing machines with finite tape. A Turing machine consists of a pin that can perform a variety of actions in an algorithmic manner. The original paper lists 5 extremely simple actions that such a pin could take, adding together to produce a much more complicated algorithm. 1. It can read the symbol it's on and store it. 2. It can write to the space it's currently positioned on. 3. It can move left on the tape. 4. It can move right. And 5. It can halt the process, leaving just the tape. Turing proved that you can run any valid algorithm using just these simple functions. I tried to demonstrate by making a half adder from the last video on one, but due to the simplicity of Turing machines, it got complicated fast. Turing machines are very useful as a mathematical basis for computer algorithms. While modern silicon computers have far surpassed levels useful for Turing machine proofs, they are very commonly used with some modifications in quantum computing, as our best attempts have only reached 90 qubits, and proof of concepts are still very common in the field, although it's growing fast. Alan Turing would go on to help fight Nazi Germany in World War II by attempting to break its Enigma code. It's estimated that without his contribution, the war would have lasted 2 years longer than it did, and over 14 million potential lives would have been lost. When he returned from the war, he was arrested after it was discovered that he was a homosexual, and after losing his job and his career was ruined, he killed himself by taking a bite of an apple laced with cyanide.